So good afternoon. It's 3 minutes past 1 o'clock, so it's time to start. I think you can see me and hear me. Please say yes.
Yes.
Okay, thank you. I think you are also. There is also my presentation on your screens, so we can go on as we are used, starting from the general part. This is lecture number 6, and sorry. This is the material. I've uploaded the new video of lecture 5, and the rest I think is the same of the other of the past lecture. Nothing to say about this. Yes, this is something related to the next lectures, and if you remember, there was this open question of the 2nd of April, because normally it's holiday, but there was the opportunity to have a short lesson in order to train ourselves for the following test that is scheduled for the 7th of April. If this is right for you, we have only to decide the time, because I remember that some of you told that it was possible to change the time, not 1 o'clock in the afternoon, but before in the morning. Did you check if it's possible to move the lecture?
No, Professor. We didn't. Haven't asked the professors yet.
Okay, so I leave it as it is, and we can then decide next time. Okay.
Yeah, maybe I will ask next week, and then I will let you know by email if.
Okay. Okay. Thank you. Thank you. So this means that you, Faras, are the tutor of the course, or?
No, I'm not.
No. No tutor at the moment.
Yeah.
This is the proposal for the exams. I think we can then fix the first part for the 7th of April. So we will be able to train the week before, and the rest I think is not necessary to discuss now. About the presentation, there are a lot of new proposals. I would like to open the file, just a moment. Here. And here. So at the moment, I've received 1, 2, 3, 4, 5, 6, 7 proposals. If I forgot something, please let me know. I think there is still something to complete for the first presentation, because It is a proposal from Yannis, and as I said, I would really prefer that the students work in pairs or with a group of 2 students. And the other open question was about the second, because there was still a choice to make or 3D printing or wood plastic composite from Ronian and Tom. I don't know if they have finally decided. In any case, let me know, and I will adjust this file. If other students would like to do this activity, please let me know. If you need suggestions or specific request of material and so on, just write an email to me, and I will be glad to help you. The last, this I think I can close. And again, okay, just a moment. So the last slide for the introduction is about the program for today. We will revise the program. In particular, I prepare some pictures about more or less all the subjects related to wood that we have learned during the last lectures. Then I would like to go on and to really finish the subject, considering with you what is known as modified wood. There is also something I would like to add is the terminology session, where I try to repeat all the strange and difficult terms we have learned during the last lectures. And finally, if there is time, I promise to you to give you some tips for your presentation. It's not an official part of the course, but I told you many times that I like to share my experience with you, considering the preparation and the way to present something. I hope it could be helpful for your presentation in this case, but I think as a general suggestions that can be useful, I hope, for you also in the future, for your future career, when you will be asked to present something in front of other people. Normally, it seems easy, but very often people make some mistakes because of the psychological difficulties we have when we are in front of other people and we have to present something. In any case, this is the subject of the last part. If there is enough time. Now I would like to share this okay. Now I think you can see this presentation, which title is Wood Pictures. Can you see it?
Yes, we can see it.
Okay. This time we will simply repeat what we have already learned, and with the help of some pictures. Some of them are nice, some of them are more boring, but I think it's necessary to go on considering again what we have presented during the last lecture. This is something to remember, that wood is a material which is present everywhere around us. Even in some cases that are not common, like bicycles or glasses or other fashion products. This is a concept car from Toyota called Fazuna, made again with wood. This is a picture I took some years ago inside an old Italian university, and you see that with wood it's possible also to produce chemical benches like this one. It's very old, but still in good shape. Not many people know that the most important page of the human history is painted on wood, because behind the Gioconda from Leonardo, there is a table of poplars. So it's made with wood, and it's interesting to note that it was painted around 500 years ago, and it is still in good shape. So it means that wood can resist many years, and this is a clear example of such durability. Then we have repeated many times the story of the greenhouse effect caused by the accumulation of CO2 in the atmosphere. This is the website of the American Space Agency, which gives the indication of the concentration of CO2 in the atmosphere, and we see that for the reason we know very well now, it's increasing continuously. You see here from let me try to use the pointer. You see here from 2007, there was a tremendous increase in the concentration of CO2, and this line is going to further increase in the following years, with all the consequences we know very well. We have described why the use of wood can be important. not to stop, but to reduce the concentration of CO2 in the air, allowing more time for human beings to find another energy source to solve definitely this problem. There are on internet different websites dealing with the CO2 problem, and also with the calculation of the CO2 which is stored inside an object. It's becoming such a story of CO2 is becoming day by day more important, and also more known by the people, because we are every day in contact with news describing the problem and so on and so on. So this is something it's you can easily find in internet with different approaches. This is something I would like to share with you. I have in my house a fireplace like this one, and for me it's nice to think that considering that wood is formed by this reaction, you know, the photosynthesis, where CO2 and water are combined together thanks to the energy of the sun to produce cellulose and the other wood components. So when we burn our wood in our fireplace, we do exactly the opposite reaction. So we combine cellulose or wood in any case with oxygen, which is present in the air of our house, and we produce CO2, which is emitted outside water, and the energy that we feel as heat. And this energy is the same that was stored here, used here by the tree. So what we feel as energy is the energy deriving from the sun. So sometimes when I stay at home in front of my fireplace, I think that the heat I feel is the heat of the sun. It's a sun power device, what I have in my house. It's something I think nothing new, nothing special, but it was something I'd like to share with you. So when we burn wood, what we feel as heat in a certain way is the energy deriving from the sun. We talked about the problem of illegal wood, and now we know that there are some specific laws, in some cases also very strict, which try to counteract the market of illegal wood. In Europe, we have this EU TR. EU means Europe, and TR means timber regulation. So it's a regulation which is in practice a law which is valid for all European countries, which tries to counteract the import of illegal wood. Today we know that the wood used for construction of buildings, or furniture, or cars, as we have seen, bicycles, normally derive from plantations. So today trees are a product of the agriculture, with similar to other products of the sector. So you can see also in our countries many places where trees are cultivated, and there are also some benefits we mentioned deriving from the cultivation, because the tree grows in a controlled way. You can see some examples of trees growing in areas with a lot of wind, which is able to deform, to bend the tree. Or in other cases, like this is a picture I took in Austria years ago. You can imagine that this wood, it's we can say a difficult wood with a lot of tension inside, which is not possible to be used for application, for industrial applications. So this is, on the contrary, very homogeneous. All the plants more or less produce the same wood with the same characteristics. So it's more usable for the industry. We know also how the tree grows, so now we we know that it can be a problem to let a bicycle or a motor like this one close to a tree, because the tree grows on his external circumference, and like in this case, after some years, the tree can incorporate our bicycle, our motor, like in this example. It's a real picture, so it's not a fake. We know also something more now about the morphology of the tree, the story of softwood, hardwood, the bark on the outside, and all the consequences we know about, for example, the durability of wood and the growing wings and so on. Here you can see a piece of wood on the right. This is wood from olive tree, which is a tree growing in the Mediterranean area. So it you can say, suffer from the differentiation of the climate from the cold and hot seasons, and so we can see the differences in its growth with the wings. We can then reflect in these particular patterns when the wood is cutted. On the left, we can see a wood deriving from the central part of Africa, which is not affected by this differentiation of climate, and the growth is continuous. There is no difference from summer to winter. So the image, the appearance of this wood is more simple, without such patterns that we can expect from the wood species growing in our areas. What else? This is the story of heartwood, which is full of substances which protect wood from the biological aggressions. On the other side, the external part, the softwood, we say it many times, that is the living part of the tree, and you can see that fungi and molds are able to attack this part of wood using the nutrients which are present inside. This is the cellular structure of wood, and so from this picture we derive some of its properties. For example, the story of the anisotropy with the different cats, the radial cat, the longitudinal cat, and the tangential cat. The first consequence is the appearance with the radial cat. Here you see the wood surface appear like in the form of strips, as you can see here. In the case of tangential cat, this cat, the wood surface appears like the flames of a fire. I remember I said during the last lecture. This is the picture of my house. Here we are inside the bathroom. This is the shower, and because of the porosity, water can enter here. Was able during the years to remove the coating, to alter the wood with cracks and so on. So remember that this part of the wood, the end grain, so-called, is the most critical. So this application, especially where humid or wet environments are considered, is not a good solution. Maybe something that I'm planning to do, it would be better, for example, to cut 1 centimeter here in order to allow water to flow on the flooring without entering here and damaging the door. We know also something more about the wood composition. We said that the three main components are components of polymeric nature, particularly cellulose, lignin, and hemicellulose. And the last time we have made a comparison with reinforced concrete. We said that cellulose is in the case of reinforced concrete, is represented by the steel bars, and the lignin represent the concrete which bind together all the steel bars, and hemicellulose is in the reinforced concrete. There is no such comparison, but is a sort of adhesive which bond together the cellulose with the binder with the lignin. This is an example of blue stain fungi. It seems nice, but it was not the aim of the owner of this house to have this blue stain. This derived from the aggression of blue stain fungi, as we said. Blue stain fungi is not dangerous because this fungi uses the nutrients which are already present inside the food cells, so sugars, starches, and so on. So it does not alter the polymeric components. And in this case, the fungi was different, was the destroy fungi, which is able to use cellulose and in some cases also lignin as nutrient. So you can see the disasters caused by this type of fungi. What is important to know is that we said also last time that fungi of all species are able to grow only in very humid places. So this disaster can derive only from very humid places. So only when wood is wetted, so when its moisture content is above the 20%. So if wood is properly protected, this this disaster never happened. This is the aggression from the insects. And then we have analyzed this story of wood and water. We have repeated many times that there are two words describing wood in terms of properties. The first is anisotropy, and we know the meaning of anisotropy. The second is hygroscopicity. Hygroscopicity means that the wood is always sensitive to water. When wood is alive inside the tree, the tree, the cell contains a lot of water, free water running inside the cells, and the bound water, which is the water bounded with the polar attractions with the cellulose. When the tree is cutted, all free water is quickly released from the cells, and what remains is only the bound water, which is then establishes an equilibrium with the environment where the wood element is placed, and so the content of bound water can vary normally from the 0% when wood is dried, for example, inside an oven, to a maximum of 30% when wood is placed in a very humid environment. So normally in indoor conditions, the moisture content of wood is around 10%. Normally, it's said that the typical moisture content of a piece of wood is ranks from the 8 up to the 12%. This is what we've already said. This is a piece of wood, and you see with the F the amount of free water that was present inside this piece of wood when the tree was alive. And this bottle represents the water which is present in this piece of wood as bound water, so as water linked to the to the cellulose, and the entire bottle is the maximum possible content of water at the fiber saturation point. B1 is the water which is present inside this piece of wood in normal condition. Here they say around the 8% of moisture content. This is a suggestion. Again, if you have a fireplace in your house, because we said wood contain always water, remember that when you buy wood for your fireplace, the moisture content, it's very important. It's a parameter that you should ask to the seller, and the reason is that you want to buy wood that burns inside your fireplace and not water. So you can understand if you buy a piece of wood or some elements with a moisture content of 10%, it's good. If you buy the same wood with a moisture content of 30%, you pay for water. You pay, sorry, for wood. What is water? And there is another problem because if you burn humid water, humid wood, part of the energy that is produced by burning is used to evaporate the water which is present inside wood. So you lose a lot of energy because, as I said, some of the energy of the combustion is not transmitted to you as heat, but it is used by water to evaporate. And you know that the amount of energy required by water to evaporate is normally very high. So remember, when you buy wood for your fireplace, always ask the moisture content for two reasons. The first is that you don't want to pay to buy water instead of wood. And the second is that if you burn wet wood, the efficiency of your heating system would be very poor, because you lose a lot of energy only to evaporate the water you have inside your wood piece. Oh, this is I call it a movie regarding the story of wood movement. So this is the representation of a cellulose molecule with these OH groups. You can see this representation of its polarity with a little positive charge on the hydrogen atom and a little negative charge on the oxygen atom. So this means that when we have more cellulose molecules together, there is a strong attraction between among them, and so they are very close to each other. And this also, we said many times, represents the little secret of the high strength of this material. We know that there is another molecule which is very polar. It's water. Again, the two little positive charges on the hydrogen atoms and one bigger negative charge on the oxygen atom. So we know now what happens when we are in a dry environment. There is a little amount of water in the air, so the cellulose molecules are able to come in mutual contact with each other. But when the environment became humid because of the rain, because of other possible factors, water is able to enter inside the wood structure, and there is this competition between wood and cellulose with these polar attractions. And so, because water is entering, the two cellulose molecules they start to separate each other, and the wood swells. Sorry, let's not go in the other direction. So wood swells. And then we go back to a dry environment because the climate has changed, or because we have switched on the heating system. The humidity increases. Water is released from wood, and wood shrinks again. So this is something that continuously happens. Wood swells and wood shrinks continuously during all the life of every wood element you have in your house, or whatever wood object exists in the world. These are again some bad examples of what can happen with this story of wood swelling, some flooring, kitchen, serious disaster here. Maybe this was caused by running water, because it's too much for a simple variation of the relative humidity in the air. Maybe there was an accident with water flowing on the floor and creating this big problem. Also, this one for sure was generated by some problems of the water connections or something else. But it's real. Again, this is a museum. Maybe some rain falling down from the roof. I don't know, but these are dramatic examples of what can happen with wood and water. So remember, always consider this story of wood shrinking in wood as well. This is a part of the cabinet door. Maybe when was produced, the molecular content of the element on the right was different from the element on the left. And so after some weeks, the wood come to equilibrium with this determination. Again, is this, in your opinion, a defect? We can see sometimes the wood trunks with this split. Is it, can we consider a defect, in your opinion, or is there an explanation to to describe this this behavior that we can see very often with plants after drying. Any idea? No, I don't see any hand up. And the reason is simply this. If you remember, we said that the good movements in terms of swelling and shrinking are different along the three directions. So the movements of wood are anisotropic. So the movement in the tangential direction, we said, are more or less double than the movements in the radial direction. So it's quite easy to derive that this is what's normally happening, because the movement in this direction is higher than the movements in this direction. So it's something that normally happens when wood is dried. And as an example, you can see this wooden beam.
Excuse me, Professor.
Yes, please.
Excuse me for interrupting, but we can't hear you clearly. There is some background noise.
Oh, I'm sorry, because there is nothing around me.
I think all of us, we can hear it now.
Sorry, please.
I don't know if it's only me from my computer or it's we all hear the same noise.
No, we are all hearing the same noise, I think.
So I don't know. Now it's better.
No, it's still there.
Decrease the volume of what about now? It seems better or not?
No, it's still the same noise. Oh, yeah.
Okay.
We can't hear your explanation clearly.
Tell me something. Can you hear me?
Yes, we can hear you, Professor.
Yes, I think it is a problem of your microphone. If you have some earphones, maybe we can hear better.
But I don't have with me at the moment. Sorry.
Okay, sorry. In this case,
yeah, we can just continue.
Let me try with. What about now? Is it better or not?
I think it's a little bit
Tell
fast.
me if it's better or not.
No, I don't think so. No, it's still there. It's okay, Professor. We can continue. Sorry for the interruption.
Can you hear me, please?
Yes, we can hear you.
Can you hear me?
Yes, Professor. We can hear you.
Faras, can you hear me?
Yes, Professor. I can hear you.
I'm sorry, but I don't know if you are hear me or not.
Professor, yes, we can hear you.
Yes, we can hear you.
You. Okay. So can I go on?
Yes, Professor. Sorry for the interruption.
Okay, as far as is telling me that you can hear me. Okay, now it seems that okay, maybe now I can also hear you. So I was here describing that wooden beams frequently present this split, and the reason is that it derives from the difference in the shrinking in the tangential direction, which is, we said, double than in the radial direction. This is the way how we can calculate the moisture content of a piece of wood. It's normally calculated by weighing a piece of wood, then putting it inside an oven for 1 day and weighing again the piece of wood. So the moisture content is calculated considering the weight of water by the weight of the dry piece of wood after drying. There are also some systems that can give you a quick measure with this resistance multimeters. I think it's quite easy to understand that the higher is the moisture content, the higher is also the conductivity, electrical conductivity of the wood element. So there is here inside a system which is able to transform the electrical conductivity in moisture content in terms of percent. Another system is dielectric multimeters. The advantage is that you don't affect your piece of wood, because here you have to insert these two electrodes inside the wood. So after you see 2 little holes, in this case, you don't see any damage because it's only carried out by the contact of the electric system with the wood surface. The story of lignin, we said last time what happened when it is exposed to the sunlight. Remember the degradation of lignin, which is the first step of the degradation of wood. We said that this substance is a thermoplastic polymer, so some companies were able to use it like a plastic. This is an example of the use of lignin instead of the most common polymers, artificial polymers we know. We said something also about wood extractives. Some of them are soluble in water, so this is something that's happened sometimes with certain wood species. Water is able to dissolve these extractives, and then removing them and creating, in some cases, some spots in the floor or in other part of the houses. Again, this story of the tannins, in particular, which are present in oak, and if water is exposed to water, these extractives are able to migrate toward the surface and create these dark spots, which are not nice to be seen. This is the door. Again, it was the door of a bathroom, and again the problem of the tannins running out to the surface. This is the kitchen. You see here we have an oven. So when the oven is open, the vapor can go up, humidifying the surface and creating during time this bad spots which are not nice to be seen. Again, another case, kitchen. Also here you can easily imagine that water can humidify this spot. These are good. This one which is just near the sea is full of dark spots deriving from the phenomenon we have already mentioned. Again, I already told you that the problem is that today architects and designers, they like wood, but they want natural appearance. So when you touch this surface, they say you have to feel the wood structure, the wood grain. But this means that wood is not adequately protected. Water can enter and create these problems. The negative the negative consequence is that the final users normally say we will never buy a kitchen made of wood in the future because wood presents many problems, and maybe the next kitchen boat will be made of steel or plastics or laminates, only because the designers do not know how to deal with they know the basics of what we know in 4 or 5 lectures. I think that this kind of mistake we will never do in the future. We said also that the wood extractives are also responsible to the color variation of this material when exposed to light. Also the light of our houses, the light of our lamps is able to change the color of our wood flooring in this case. And it's very common to see, for example, that under a carpet, we can see still the original color of the wood flooring in the part which was exposed to the light, to the light of the of our lamps. The color has changed. This is again something that sometimes is not accepted by the final users, but it's something natural. Wood change is appearance in consequence to the exposure to the light, and you cannot stop this phenomenon. It's something natural. It's like my hairs that were dark some years ago. Now I'm 60 and my hairs now are gray. It's the nature. You cannot you cannot stop what nature normally does during time. So it's something that must be accepted. Normally, I say to the users of wood change with you, like your wife, like your children, also would change. It's something natural. You must accept it. Finally, some slides about this story of good durability. It is good durable material. Some people say yes, some others say no. Normally, when people ask me if wood can last for a long time, normally I show this picture is an olive tree in Sardinia, and the age of this tree is estimated in 500 years. So I think this is an example that wood can resist outdoor more than any other material you know. Just to say how the tree reacts to the environment. We know that bark is a protective shield. Some trees are colored with this white colors, birch, for example, to prevent the effects of the temperature variations. So, these trees normally grow in cold areas, and so if during the day they are heated too much, during the night the temperature fall down, and so this combination of heating and cooling could create cracks on the tree. So the tree protects itself with this white color in order to prevent an excessive heating of its trunk. So wood is able to protect itself from the light. Some trees, we know, like pines, they have this nice bark made of little particles which are continuously lost or renovated. So you can say that the trees they do a continuous maintenance of their protective shields, and they do also what we can call extraordinary maintenance. If an accident was able to break a part of the tree start to direct appropriate raising in this part, and see these drops of raising in order to protect in case of accident. So the tree do a normal continuous maintenance, and also in some cases an extraordinary maintenance in case of particularly accident. We know that the tree protects itself also using some preservatives, natural preservatives in this part against living organisms. And in some areas where water is a possible problem, this is the rainforest. So every day, more or less, there is rain coming from the natural place where they are. This wood species protect themselves by synthesizing oils or waxes which protect the tree and also the leaves from the excessive of water. And the people living in this area uses this woods to use this simple sheets because they are completely safe against water. They are full of hydrophobic substances, and so again, wood is also able to protect itself from water. This is a nice, a very bad example of how architects and engineers do not know wood. They built some years ago this house, and not far from here, and they didn't consider that wood is sensitive to water. You can see the disasters. The house is totally new, but after a couple of years, it was completely destroyed by water, and the reason is not because it was made with wood, but because it was made by people not knowing enough how to treat wood. And again, it's a very bad message because the people, when they see this, they say, "Oh, I will never buy a house made of wood because wood is not durable." It's not true, but wood must be known, as I repeat many times. The final slide I have is this. We know that wood dust is dangerous and can cause cancer. So in some countries, this is I think from California, they have to apply this label that is wood, but there is a label telling that this product can generate wood dust, which can cause cancer. And this is all for this part dedicated to a quick review of what we said about wood. It's 10 past 2. I think we can have a short break, so we can meet here in 10-15 minutes. Okay?
Sorry, can I ask you one thing?
Yes, please.
We discussed on the group, and if it's we can ask you if it's better to do the exam on the 9th, on Friday of April, instead of Wednesday, because at least it is at 1 p.m. and not at 4 p.m.
Okay.
If it's not a problem.
No, it's not a problem for me. So for the 7th, we will have the normal lecture.
Yeah.
And for the 19, we will have the exam. So in this case, I think it's better to have a normal lecture on the 2nd, maybe a shorter lecture, and the preparation for the exam we can postpone it to the 7th. So you have more than 1 week to prepare for the exam. So the 7th I think is not good to add new material if the exam is today after. It's all right.
Okay, perfect. Thank you.
Okay. So see you in 15 minutes. We can say 2:30. Okay. Okay.
Yes, okay, Professor. See you then.
Thank you.
So welcome again, and it's 2:30, and I would like to go on. I don't know if I will be able to do all the parts that I've told to you, but in any case, I would like to introduce to you the modified Wood, and then we will see if we have enough time or if we have to postpone the other two parts of the program for today to the next lecture. So let's go on with this interesting part. Sorry. Here. So we are in this appendix dedicated to modified Wood. The program for this part is a short introduction about the subject, and we will consider the physical treatment to modify this material with temperature or with pressure or both. The chemical treatments, considering treatments that affect the bulk of the wood, or some other treatments which affect only its surface. I've added here also the impregnation, which is not really a modification of wood. It's something related with the filling of its internal voids with other substances, but because it's quite similar in terms of result with the rest, I've introduced wood impregnation in this part. It is not properly a modification of this material. So what about introduction? This is something we know now very well. Would present a lot of positive elements, low density, very good mechanical properties, good insulation properties in terms of thermal and acoustic, very nice appearance. It's renewable, and it can be recycled until the end of its life, when we can use it even as a material to produce energy. So very, very good impact with industrial processes, with our daily life, and also with the environment, because of many reasons we have already considered many times. But we know also that wood presents some weak points. It's sensitive to biological degradation, it's sensitive to UV radiation, it's anisotropic and hygroscopic, and also this problem of the directional absorption of liquids we have considered during also this lecture in the previous part. How can we improve good properties? There are normally three strategies we can use, or we can also combine together. We can apply some artificial preservatives, especially to counteract the biological degradation with the surface application. We have some the results can be very good, but remember of the safety, because these products that use as preservatives normally are dangerous also for the human being. So we have also to consider their benefits, but also the possible negative consequences on our safety. In the past, we were used to use very, very good but dangerous substances like some metals, like arsenic, like chromium, that were fantastic in order to protect wood, but on the other side, they represent a serious risk for our safety. So today, some of the good preservatives that were used in the past today are completely banned, and one of the analyses that normally we carry out here in CARPES is to the research of such old preservatives that can be still present in wood. The second possible strategy is the use of transparent coatings or paints applied on the surface. Normally, they protect wood, of course, but they are not able to completely isolate the wood substrate. They slow down, for example, the absorption or release of water, but they are never able to completely avoid this continuous exchange of moisture with the environment, and moreover, they need maintenance. If you have wooden windows in your house, normally what I recommend is an inspection every year and maintenance every 2 or 3 years, depending on where the windows are places, in which countries, or even if they are exposed towards south or towards north. In any case, the use of coatings and paints is a good solution, but you have to consider the regular maintenance. And the third one is wood modification. That is the subject of this short presentation. Okay, so what is modified wood? It's not a new subject. It's more than a century that researchers are dealing with some subject to try to modify the chemical nature of this material with different approaches in order to make this material more resistant, especially to the degradation factor, especially when wood is exposed outdoors. This is more or less a definition of what is modified wood. You can see here a structure, interesting structure made with this nice and durable material. Modified wood can be defined as the result of chemical, physical, enzymatic treatment, so that wood is improved in some of its properties, such as biological resistance, dimensional stability, and resistance to aging. Normally, the first purpose of wood modification is to reduce the sensitivity of wood toward water. It's clear that if you are able to reduce this sensitivity, you reduce as a consequence also its biological sensitivity, and you improve the dimensional stability, because biological resistance, especially against fungi, is strongly connected with water absorption, and also dimensional stability is connected with the exchange of water with the environment. So if you are able to reduce the sensitivity to water, you immediately improve such properties of this material. I've already said what are the modification principles, physical, chemical, and intonation. Let's see, first of all, the physical treatment based on the temperature. It's a quite simple treatment. Normally when I present a thermal treatment, I say that wood is cooked inside an oven, like you cook biscuits, like you cook bread or your pizza or whatever in your oven. You can do the same with wood. As you see, you have to reach such temperatures from 150 up to 240 degrees, and simply putting your wood elements inside the oven for a certain time with a certain heating rate and so on, using, for example, some gases. You can, as I said, cook your wood. It becomes brown normally as your bread. When you put your bread inside the oven, after some minutes, it becomes darker. The same happens with wood. The treatment is permanent, and as we will see, this thermal treatment exactly is able to reduce the sensitivity of wood to waters, but the results depend on the wood species and, of course, on the type of treatment, for example, on the temperature, the time, and so on. This is an example of thermal process of poplar. It's not much to see. This is the finished result. You know that poplar is a very light color wood, and after the treatment, as you see, it becomes very dark. The video is quite boring, I think, but you can see the wooden elements that are simply inserted in this big oven, and as you said, the oven is switched on at a certain temperature for a certain time. Some gases can be used, so there are around the world different treatments according to different producers. So you can find on the market different types of thermal treated wood. There are also some brands, especially in the European northern countries, where this type of wood is very common, especially for certain applications, in particular for the application of outdoor products. Okay, they are advertising their oven. Not much interesting for us, but now they say that after the cooking of wood, then you can work out your elements like normal wood. I think we can stop here with this video. It's just a description of what you get the wood cooking. What are the effects on the chemical composition of wood? I have to say that it's not really clear what happened, because heat produces presumably different effects, different reactions inside the wood structure. For sure, there is the degradation of the lignin. Lignin is a polysaccharide, so it is full of OH group like cellulose. So the degradation of hemicellulose produces by itself a reduction in the sensitivity of wood toward water. But what happened, there are some studies which confirm that the byproduct of hemicellulose degradation, which are represented by some acid like acetic acid and others, are able to react with the OH group of cellulose. So this acetic acid, for example, reacts with the OH group. So finally, the thermal treated wood present a lower number of OH group compared to we can say normal wood. So the sensitivity toward water is reduced because there are less OH group in the wood components of thermal treated wood. You see what happened in terms of color to the wood surface or to the wood bulk, because it's a treatment affecting all the bulk of the wood, and as happens also with the oven we have in our houses, the higher is the temperature, the darker is also the color of the element we put inside our oven. Here you see this is fine before and after the treatment. You see the considerable variation in color, and because I've already said we have reduced its sensitivity toward water, we have improved its dimensional stability, and we have also improved its resistance towards biological degradation. You can see in this picture here, this element was not treated on the right. The element on the left was thermal treated, and we see the aggression of fungi on the right and not on the left. Dark color for wood containing a lot of raising, the heating to promote also the removal of the raising, and because of the reduced amount of water inside wood, also the thermal conductivity is reduced. The wood is more insulating. This is a thesis we carried out some years ago with a student of the University of Trieste. We tested the American red oak treated at two different temperatures. You can see here 190 degrees and 210 degrees. The density, and this is the natural American wood without any treatment. You see that the density is reduced by the treatment simply because the moisture content is reduced. You see, around 10% is removed for the non-treated wood, and more or less the half for the treated wood. So this is clear evidence that thermotreated wood is considerably less sensitive to water. Of course, also shrinkage, vitamin shrinkage is reduced. This is an experiment carried out here in Qatar, and we calculate, it's better to say that Roberto calculated the shrinkage between good condition at 20 and 65% of humidity to any wood until the wood, the moisture content was practically zero. And you see the variation tangential, sorry, it should be the opposite. It's a mistake, of course, here. In any case, the variation is exactly around the half for treated wood than non-treated wood. Sorry for this mistake, it's exactly the opposite. This is radial and this is tangential. But in any case, what is clear is that movements are considerably reduced. There are some important drawbacks to remember. The first is the most important. The mechanical resistance of this material is strongly reduced. So, thermally treated wood is good for many reasons, but the mechanical resistance is also considerably reduced, and this can be a problem, especially for building elements. Color is dark, but not always stable to light. We have already mentioned that we get different results using different wood species, and also different results deriving from different treatments. So if you want to buy thermally treated pine, it's okay, but the properties depend on which treatment is the subject. So we speak about thermal treated pine, we cannot say which are its properties, because its properties depend on the treatment. So the thermal treated pine deriving from one company could be completely different from the thermally treated pine deriving from another company. So let's consider that its natural properties are changed, but the level of change depends on the treatment itself. And finally, this is not something to forget. Thermal treated wood normally has a bad smell of something burned. I really hate thermal treated wood because of the smell it has. I cannot imagine to use thermal treated wood, for example, for the flooring of my house, because when you enter inside the room with flooring made of thermal treated wood, you can immediately smell this burned wood, and I really do not appreciate. So for me, it's all right in experience places, outdoor, good, indoor. I have some notes about its suitability. Smell is it's a sensation that can create real problems. If you live in a place you don't like the smell, you don't feel good. And again, architects and designers have to know also that thermal treated wood can be nice, can be good with very good properties, but try also with your nose what is the sensation. This is again the thesis of Roberto, showing us some results of the mechanical tests, and you see that the bending strength is reduced, is dramatically reduced, is around the half for already treated at 210 degrees. So it's strong decay of the mechanical properties of this type of wood. Where it's possible to use outdoor, as I said before, throwing no barriers, indoor again, throwing, I don't know, also sauna, I don't know, it's good. But never use thermal treated wood for buildings, for building part which must be subject to loads during their use. So flooring is okay, but not always. Garden furniture, some other elements, but not subject to load. Pressure treatments. This is these slides I took from a colleague of you, Yassine, last year presented this densified wood, and I found interesting. So I'm using 2 or 3 slides taken from him. The background of this treatment is simply to compress wood. You see here magnification of wood with all the voids deriving from the cells. So some people invented this process of simply pressing it in order to reduce the space inside. So the final product is called densified wood. It's simply wood that was pressure, sorry, this treatment, it was initially treated with a chemical treatment in order to remove part of the lignin, and then it was pressed with a reduction in thickness around 80%. So very, very big reduction of the volume, with the consequence also a considerable increase in its density. This is the first part, which it's the chemical process which is used to remove partially remove lignin, so it became some more flexible, and the second is the reduction in its volume. The dimensional stability, strength, and hardness are improved a lot, around 10 times. The drawback is, of course, that the density is considerably higher than normal wood. What we know also from other papers on the right is that it can be good to use as a structural material for buildings, and the colleague found also other applications like line building blades or body armor, because it's material which is also resistant to possible impact with guns and so on. Let's consider chemical treatments, bulk treatment. We know very well this story of the polarity of cellulose. I don't want to repeat it. We have considered many times during this course. And we know also what happened with the presence of water, the shrinking, swelling, and so on, caused by this polar interactions. What was the idea of some people some years ago? It was to activate chemical reaction between such OH groups and another substance. It was the acetic anhydride with chemical reaction which is known as esterification. This is acetic anhydride. These are the OH group of cellulose. So this chemical reaction is promoted. We don't have the OH group anymore. They are substituted with this acetate groups. And so this part of the cellulose molecule is now not sensitive towards water. With the plants we have seen here, they are very complex. There is one plant in Holland I visited some years ago. And it's a production plant. It's not a reserve. It's a real production plant. You can buy this acetylated wood together with the other wood species, and you can I think imagine that this wood is less sensitive to water, but it's also more resistant than thermoset wood in terms of mechanical use. This is a short video deriving from the producer of this wood. They advertise a little bit this Accoya wood. Okay, I don't think it's necessary to hear what to say. This is the chemical reaction I've already mentioned. OH group of wood, the second wood, create this acetylated wood, which is then more stable with the production line. Let me see if there are some elements, wooden elements on the beach, houses made of circulated wood, very close to the sea, so exposed to severe climate. They say that it's 100% acetylated also inside, so you can you can work with piece of wood. You can sew it, you can mill, you can sand, and the properties remain the same. This is more or less how they show the production of this wood. Accoya is the brand of this wood. Modified wood because of some examples of uses. It's incredibly durable. I have some pictures I'd like to show you, showing how durable is this acetylated. It's possible also to use inside some channels like this, and resist many years without any try to go on. So what are the improvements of acetylated? This is an experiment that's done by myself. This is the this is a piece of acetylated wood. This is a piece of non-acetylated wood. The original dimensions were the same. I soaked them in water for 24 hours, and after you see this big dwelling of the non-treated wood, and the other remain more or less the same width as it was at the beginning. So reduce water sensitivity, reduce movement, of course, reduce biological decay because the content of water is reduced a lot. Mechanical performance are not much affected, like in the case of thermotreated wood, and the maintenance when exposed though is really reduced compared to normal.
Excuse me, Professor.
This is an experiment we've done here in Catas in 1 year.
Excuse me.
Exposed for 1 year, and you see the lignification and the erosion of the surface. Acetylated wood is still very good state. But it's another example, maybe using the UK on the left, Accoya, which is the brand describing acetylated wood, and on the left, normal wood. This is after 3 years and 6 months. You see here the comparison after 9 years and 6 months. The sample on the left is always the non-treated wood, and on the right, the acetylated wood. And this one is after 13 years, again on the left, the non-treated wood, on the right, the acetylated wood. So it's really interesting how the acetylation can improve the durability. Are there some drawbacks? Yes. Acetylation is suitable only for highly porous wood pieces because the acetic nitrate must penetrate inside the wood bulk. So, unfortunately, this treatment at the moment it's suitable only for some species very, very cold. The reaction between acetic anhydride and wood produce acetic acid as a byproduct. So the odor is that of acetic acid, not bad, but we have to consider this evidence, and also the presence of acid can represent a problem, for example, for metal treating. We know that acids are able to start to improve, to promote the corrosion of metal fittings. The cost of this material is incredibly high. I think the cost is from 3 to 5 times more than normal wood. So if you want to buy a window with articulated wood in comparison with normal wood, you must be ready to pay much more. It's not easy to propose this wood on the market. You can buy it, but also here in Italy, there are some places where you can buy this wood. The companies which sell wood, today they can sell to you normal wood of different species. They can sell you treated wood, and in some cases they can also propose to you this Accoya or articulated wood. Question mark refer to bonding and coating processes, because the glues and the coatings are formulated for normal wood, and in this case it's better to verify if such treatments are good also for acetylated wood. Some examples of nice construction boards, flooring, bridges, windows, and many others. There are other modifications. I know two treatments that are not only part of the research, but they are already used to sell some specific wood. In this case, is fosforilated wood. The principle in this case is the use of sulfuric alcohol, which mainly reacts with lignin, producing a chemical reaction, bonding together the lignin molecule. So finally, wood is more stable because of these interconnections created by lignin, by sulfuric alcohol among the lignin molecules. So the dimensional stability is improved by this reaction, and also because the sulfur enters and prevents the ingress of water, simply because of the alcohol occupies the voids where water cannot enter. The trade name is Keboli. Another I don't want you to mention this very complex molecule, DNDHEU, the image of the molecule on the right. And again, the result is mainly due to the phospholipid promoted by this molecule. The trade name of this chemical modified good is Belmador. It was invented in France. Here there are some evidences of this chemical treated good. My opinion is not very nice, but for sure it's durable. So it's good, and it's more durable than normal good. Some other examples are indication of how good is the chemical treated good compared to normal good. Surface treatment, not much to say. Okay, here table, but I want like to focus on the possible surface reaction of silane, which are a particular type of chemicals which create a sort of barrier against water. So it's not a bulk treatment, it's only surface treatment, preventing a lot the possible diffusion of water inside it. Very good, very nice, but in many years of activity, I've never seen a product treated with such substances. Just this morning, I had a contact with a company which is expert in the restoration of ancient wooden objects, and they asked me to help in understanding if such products are good or not. So maybe we will start a collaboration just to understand if what we see in these pictures is real, is durable or not. It's an interesting option, but as I said, I've never seen real application in the products of the furniture or wooden sector. This could be something you can investigate, for example, in one of your presentations. The last part is impregnation. Impregnation, I already said that is not a real real modification of wood. It's simply based on the filling of the cell lumen of the cell voids with other substances. Here's a video here, which is very good in describing what happened during the impregnation of wood. The wood is placed inside this chamber, which controls pressure. The step one is the removal of all the air present inside this chamber. Or the void is created inside the chamber. The step two the chamber is filled with the chemicals we want to use. They can be pigments, water repellents, fire protecting additives, or others. Now the chamber is filled with the chemicals, and then another pressure is applied. In this case, we push the substances to enter inside wood. You see from the video what happened. The story is not finished because now we have to remove the liquid, the chemical from the timber. The pressure is again reduced in order to remove the excess of chemicals from the inside of the wood element. And the final step is to bring the pressure to the normal value, and then we can now open the chamber, and our wood is filled inside with the chemicals we want to use to modify to certain properties of wood. That was a nice video. What can we do with wood impregnation?
Excuse me, Professor.
Okay, I'm again here. Sorry, there was a problem in my connection.
Okay.
Can you see the presentation? Maybe not.
No.
No, Professor, we can't see it. Yes, now we can see it.
Okay. Sorry for this problem, but it's related with the internet connection. So what can we improve with the impregnation? Of course, biological durability, if we use the wood preservatives, of course, we can reduce movement. If we, for example, if we simply fill the wood voids with some resin, for example, we can fill with other substances to increase the hardness, the density, so the fire resistance, and so on. So it's an option to put inside wood the substances we intend to use to improve the certain performances. I would like just to finish this presentation showing you an example. This is a German company called Bauerholz, and they invented this wood, also means wood in German, I think. They fill wood with waxes, and the result is that they improve the dimensional stability, the sensitivity to water, and wood can be used also in critical application like the ones you see here. One of the problems of this wood treated with waxes is that it's very difficult to be bonded with adhesive or to be coated with varnishes or paints. But this company, this German company, was good to promote not only the wood itself, but also they can sell to you the products, the adhesive and the coating to bond or to coat this diaphragm. So a complete service from this German company. That's all for modified wood. Very quickly, 10 minutes, not more, to see the dictionary. Sorry, but I received a message, but you say that there is a poor connection. I'm sorry, maybe
Professor, can you hear us?
yes, I can hear you.
Okay.
Can you hear me?
Yes. Yes, we can. But there is a strong noise when you speak.
Okay, so if you agree, because it's 3:30, we can finish the lecture now. And maybe for the next time, I try to find another possibility. It's okay for you?
Yes, if you find some earphones, it is better.
Okay, okay. So sorry, and have a nice weekend, and see you next week.
Okay, thank you, Professor.
Thank you. Thank
you, sir.
Have a nice weekend.
Thank you.
Thank you very much and have a nice weekend.
Thank you. Bye bye.
Thank you. Bye.
Thank you. Goodbye.
Have a nice weekend.